Oceans overheating. Are we at a climate tipping point? The oceans are reaching boiling point. Are we witnessing a climate tipping point? Imagine a world where the oceans, our planet's thermostat, are overheating at an unprecedented rate. Welcome to 2023, where the most intense and prolonged marine heat waves, MHWs, in recorded history are sending shockwaves through the global climate system. But here's where it gets alarming. Scientists warned that these events may be the canary in the coal mine, signaling an impending climate tipping point. What are marine heat waves, and why should we care? MHWs are extreme and prolonged episodes of unusually warm ocean temperatures, posing catastrophic threats to marine ecosystems. The consequences are dire: widespread coral bleaching, mass mortality events, and devastating economic impacts on fisheries and aquaculture. The scientific consensus is clear. Human-driven climate change is fueling the rapid increase in frequency and intensity of MHWs. The 2023 Marine Heatwave Crisis, a global analysis. In 2023, regions worldwide, including the North Atlantic, Tropical Pacific, South Pacific, and North Pacific, experienced extreme MHWs. To unravel the mysteries behind these events, researchers Tianyun Dong and colleagues conducted a comprehensive global analysis, combining satellite observations with ocean reanalysis data from the ECCO2 high-resolution project. The findings: unprecedented intensity and extent. The results are staggering. The 2023 MHWs shattered records for intensity, duration, and geographic extent, lasting a whopping 4 times the historical average and engulfing a staggering 96% of the global ocean surface. Regionally, the most intense warming hotspots emerged in the North Atlantic, tropical Eastern Pacific, North Pacific, and Southwest Pacific, collectively accounting for a massive 90% of oceanic heating anomalies. The North Atlantic MHW persisted for an astonishing 525 days, beginning as early as mid-2022. The Southwest Pacific event broke prior records with its vast spatial extent and prolonged duration. In the tropical Eastern Pacific, temperature anomalies soared to 1.63 degrees Celsius during the onset of El Niño, uncovering the drivers, a complex interplay. Using a mixed-layer heat budget analysis, the researchers identified diverse regional drivers contributing to the formation and persistence of these events. These include: 1. Increased solar radiation. Reduced cloud cover allowed more sunlight to warm the oceans. 2. Weakened winds. Decreased wind patterns failed to dissipate heat effectively. 3. Ocean current anomalies. Unusual ocean circulation patterns exacerbated the warming. The bigger picture: a climate tipping point on the horizon. 1. The 2023 MHWs may mark a fundamental shift in ocean atmosphere dynamics, potentially serving as an early warning of an approaching tipping point in Earth's climate system. But here's the question: are we prepared to face the consequences of such a tipping point? We want to hear from you. Do you think the 2023 MHWs are a wake-up call for immediate climate action? How can we balance economic development with the need to protect our oceans and mitigate climate change? Share your thoughts and opinions in the comments below. 2023's record marine heat waves, 96% of oceans affected, 4 times longer than average. In 2023, the world witnessed an alarming phenomenon. Marine heat waves, MHWs, engulfed a staggering 96% of the oceans, lasting 4 times longer than the historical average. This isn't just a land-based issue. The oceans are also suffering from unprecedented temperature spikes. These marine heat waves are not only becoming more intense, but are also extending their reach further than ever before. Specifically, the MHWs recorded in 2023 showcase the longest durations, the broadest expanses, and the highest intensities ever documented, and the situation in 2024 showed no signs of improvement. While the effects of heat waves on land are often felt more acutely by humans, the repercussions of MHWs are equally concerning. These heat waves disrupt delicate marine ecosystems, leading to coral bleaching, mass migrations, and the death of various marine species. Such disruptions have a cascading effect, resulting in diminished seafood availability and significant economic losses for industries reliant on marine resources. Despite the growing consensus among scientists regarding the increasing frequency and severity of MHWs, the underlying mechanisms driving these changes remain somewhat elusive. To effectively address the threats posed by deteriorating ocean conditions and to develop adaptive strategies, it is essential to deepen our understanding of these drivers. Additionally, it is crucial to explore how MHWs interconnect with other climate-related changes and what future consequences may arise. A recent study published in the journal Science shed light on the reasons behind these extreme heat waves. Researchers utilized satellite data from the ECCO2, estimating the circulation and climate of the ocean Phase 2, and the optimum interpolation sea surface temperature OISST datasets to analyze warming patterns across various oceanic regions, including the North Atlantic, tropical Eastern Pacific, North Pacific, and the Southwest Pacific around New Zealand. The findings were startling. 96% of the ocean surface experienced heat wave conditions, a significant increase from the historical average of 73.7% recorded between 1982 and 2022. The average marine temperature in 2023 was 1.3 degrees Celsius above normal, compared to a previous average of 0.98 degrees. Furthermore, the average duration of these heat waves surged to 120 days, quadrupling the historical norm. Certain regions experienced even more extreme conditions. For instance, the North Atlantic faced a relentless heat wave that lasted 525 days, with temperatures soaring up to 3 degrees Celsius above normal. In the Southwest Pacific, these conditions contributed to Cyclone Gabrielle, which caused widespread destruction in parts of New Zealand. Meanwhile, the tropical Eastern Pacific recorded temperatures peaking at 1.63 degrees Celsius above normal, coinciding with an El Niño-type event. The researchers identified several mechanisms contributing to the rise in MHWs, noting regional variations. In the North Atlantic, increased shortwave radiation was a significant factor in heating the ocean's surface. They also observed that reduced cloud cover, resulting from diminished winds and a shallower mixed layer, the upper layer of the ocean, where water properties are more uniform, played a crucial role. Similarly, the Southwest Pacific experienced reduced cloud cover and increased advection, which allowed heat to penetrate nearly 1,000 meters deeper into the ocean. In the North Pacific, the drivers included heightened shortwave radiation and decreased latent heat loss due to changes in cloud cover and atmospheric conditions. Lastly, the tropical Eastern Pacific was affected by increased advection and changes driven by El Niño. The onset of the El Niño phase was particularly significant, as it led to the warming of surface waters due to weakened trade winds and reduced upwelling of colder waters. As each year unfolds, the impacts of climate change seem to intensify, making it increasingly vital to comprehend the changes occurring in our environment. A deeper understanding of MHWs, like many other climate-related phenomena, can pave the way for more effective solutions to combat these challenges. The authors of the study express concern that these recent developments may signal the onset of even more extreme events. They caution, the extraordinary marine heat waves of 2023 may represent a major shift in oceanic and atmospheric conditions, potentially indicating an early signal of a tipping point in Earth's climate system. This article was crafted by Crystal Casau and edited by Andrew Zinnan, reflecting the diligent efforts of our editorial team. We rely on the support of readers like you to sustain independent science journalism. If you find this reporting valuable, please consider making a donation, especially on a monthly basis, to help us continue our work. In appreciation, you will receive an ad-free account. For further details, refer to the study by Tianyun Dong et al., titled Record-Breaking 2023 Marine Heatwaves, published in Science, 2025. DOI 10.1126, science.adr 0910. 7. Critical hotspots. Marine heat waves spark climate frenzy. The current state of our oceans is alarming, with climatologists in a state of heightened concern due to the emergence of multiple critical hotspots simultaneously. The oceans around the globe are shattering previous heat records, with certain areas experiencing temperatures that have reached astonishing new heights. According to the latest report from Mercator Ocean, there are currently 7 significant marine heat waves occurring worldwide. One of the most alarming situations is unfolding in the Mediterranean Sea, just off the coast of France, where water temperatures have surpassed 27 degrees Celsius, categorizing this event as severe, 3 out of 4. While the waters along the French coast have seen a slight decrease in temperature, the eastern basin, particularly towards Italy and Greece, continues to heat up day by day. In the Atlantic Ocean, a heat wave extends from the shores of France and Spain towards the east. Although this heat wave is beginning to subside, it remains intense. Meanwhile, the east coast of the United States, stretching from Canada down to Florida, is experiencing extreme heat, although there are emerging signs of potential relief. To the north, the Norwegian Sea is currently facing a new heat wave, with surface temperatures ranging from 20 to 23 degrees Celsius. This area is now classified as strong and is on the verge of reaching severe status. Overheated waters that supercharge hurricanes in the Gulf of Mexico. Particularly between southern Cuba and the Gulf, sea surface temperatures have exceeded 30 degrees Celsius, which is classified as severe. As we enter hurricane season, these excessively warm waters serve as ideal fuel for storms. Any tropical system that passes through this region has a significantly increased likelihood of developing into a powerful hurricane. In Asia, 2 additional heat waves are drawing attention. One is located in the North Pacific, between the Sea of Japan and the Sea of Okhotsk, and is intensifying, potentially reaching extreme status with temperatures above 30 degrees Celsius. The other heat wave, situated in the Bay of Bengal, remains concerning but shows signs of diminishing. A new normal for marine heat waves. Each year, these extreme water temperatures are becoming increasingly commonplace. The impact on marine life, already severe in regions like the Mediterranean, Florida, and the North Atlantic, is escalating as ecosystems struggle to adapt to these rapid changes. Corinne Durand, a specialist in extreme weather phenomena and environmental issues, Corinne Durand has been elucidating climate topics since 2009. With over 15 years of experience in both French and American media, she is also an international speaker. Having trained in communication and environmental sciences primarily in the United States, she passionately shares her insights on vast natural landscapes and the effects of climate change through her work focused on biodiversity and land management. Futura Team.